All right, so today what we're going to be doing is constructing a contour map. All right, so remember what a contour map is. A contour map is a map that has iso lines on it, and what iso lines are lines connecting points of equal value. All right, so if I have like a 10 iso line, that means every value on that line has to be exactly 10. All right, now with iso lines, let's say here's a 10 line and here's a 20 line, all right? My lines can never crisscross like that. And the reason why they can't crisscross, so like this could represent like 10 meters above sea level. On a contour map, typically what the lines represent is elevation above sea level. So that could be like 10 meters above sea level, that's 20 meters above sea level. But if my lines crisscross, the question would be, what is that point right there? Is it 10 or 20, all right? One point can't have two different values. So as a result, when you draw iso lines, they can never crisscross. They should run somewhat parallel to each other when you're drawing them. But anyways, so what we're gonna be doing today is we're gonna be drawing pretty much what it shows you on this picture here. We're gonna be drawing a contour map of this plastic volcano mountain thingy, right? And what the contour map will show us is elevations, but also give us an idea of what the shape of the land is like. And once we complete the contour map, we're going to use our contour map to calculate the gradient of each side of the mountain and see what the relationship is between how close contour lines are together and what the value of gradient is. All right. So what I'm going to do is I have this plastic box here, and on the side of the box right there, I have a piece of tape where I've marked off a depth of 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 5 centimeters, and so forth. And what I'm going to do is fill this up to the one level with water. All right. And once I've done that, what I'm going to do is put the lid on top of it, and then I'm going to take a marker, and just like it shows you in the picture there, what I'm going to do is trace where the shoreline is. All right, and then I'll take the lid off, then I'm going to fill it with water up to the 2 line, put the lid back on, and then I'm going to draw where the shoreline is. So I'm going to go all the way up till I get to the top of that plastic volcano mountain thingy. All right, so I should end up with something that looks similar to that in the picture. All right, so change the perspective here a little bit. All right, so we got it filled up to the 1 line. Take my lid, put it on top. As such, I can draw where the shoreline is. All right, take the lid off. Fill it up to the 2 line. Okay. And I draw where I see the shoreline. Take the lid off. to the 3 line. Now you gotta be careful. Sometimes these plastic volcano mountain thingies like to float, so you gotta be careful of that. The lid back on. If it starts to float, if you push it down, it should stay down once you push it down. Should probably do it. Yeah, so just have the very little tippy top of that volcano left. Right. So if you look, there's only like this much left of the volcano. So if I were to fill it up to another centimeter, it would definitely be gone. All right. So here is my map of it. We'll look at the map in a second. Just want to get rid of the mountain here and take this off. All right, so here's our contour map of that volcano mountain thingy. All right, so what we want to do now with it is we want to use this map to calculate the gradient of both sides of the volcano and see what the relationship is between how close the lines are and the value of gradient. So the side where the top of the mountain is closer to, we're going to call that the A side. So right here, we're going to call this point right here point A, and then directly opposite of it right here, we're going to call that point B. All right, and what we want to do is calculate from gradient of A to the rim, which is that spot right there. and we want to calculate the gradient from B to the rim, which is that spot right there. All right. Now, on your paper, it says that the contour interval is 10 meters. All right. So what we want to do first off is label our contour lines going up by 10s. So here's 0, 10, 20, 30, 40, 50, 60. All right. So I have my contour lines labeled. All right. So now, all right, I want to calculate the gradient from A to the rim. All right. So first off, what I need to know is what the difference in altitude is from A to the rim. All right, so A is on the 0 line, all right, and I'm going 10, 20, 30, 40, 50, 60. The top contour line right there is 60. So if I'm going from A to there, my change in altitude or my change in elevation is going to be 60 meters. Next, it says distance between A and rim. All right, so the scale of this map is 1 centimeter equals 1 kilometer, which is what this is right here. This is in centimeters right here. All right, so what I want to do is I want to measure this and then go to this scale right here to find the distance. All right, so how I'll go about doing that is, long enough. All right, so I take a piece of paper and I mark off where A is, which is right there. I mark off where the rim is on my paper, which is right there. It just so happens by coincidence, it's like the same length as a piece of paper. All right. Anyway, so I go to my scale right there and I see it's that's maybe like 6.2 kilometers. Right. So it's a little bit past 6, so maybe about 6.2 kilometers. So distance between A and rim, I got 6.2. Right. Now, calculate the gradient. Right now, the formula for gradient you should be familiar with. The formula for gradient is on the very front page of the reference tables, and it's change in field value divided by distance. All right. So in this case, my field value is my elevation. All right. So difference in altitude between A and rim is 60. So that's going to be how much my field value changed. So my change in field value is going to be 60 meters. Right. The distance from A to the rim is what I got right there, 6.2 kilometers. All right. Now I pull out my handy dandy calculator and I go 60 divided by 6.2 equals, my gradient is 9 point, I'm going to round it to the nearest tenth, so 9.7. And the units for this one would be meters per kilometer. All right. So that's the gradient of the side where the lines are closer together. Now, for the gradient from B to rim, I'm not going to do that one for you. You can do that on yourself by looking at the image on your screen. The difference altitude between B and the rim, you should be able to figure that out just by looking at the screen, because B is on the same line as A is, and they're both going to the top of the same mountain. Distance between B and rim. So you just look at the image on your screen. If you just mark off this distance on a piece of paper and then go to this scale right here, whatever that works out to be, that's what you can write right there. And then to calculate the gradient, it's just going to be that number divided by that number, just like I did on top here. All right. So when you calculate the gradient for B, all right, what you're going to try to find out is, if I look on the A side, the lines are close together. On the B side, the lines are farther apart. So when you get done with your calculations, you want to see how does the value for the gradient of B to the rim compare to the value of the gradient from A to the rim. So from B to the rim, where the lines are farther apart, do they have a smaller, do they have a larger value for gradient? That's what you want to find out. All right. Once you have the value for the gradient calculated out, then you're done with your map, and you're done with this here, and then you just have to answer the questions and write a conclusion for this. All right, that is it.